Imagine standing under a night sky, the stars twinkling like distant beacons, each one a potential world, a mystery waiting to be unraveled. What if we could travel to those stars, not in thousands or millions of years, but within a human lifetime? It sounds like science fiction, but could it ever be reality? Interstellar travel, the ability to journey between stars, is one of the most profound challenges humanity has ever imagined. But is it actually possible? And if so, how? Before we dive into the science, let's understand the scale of the problem. The closest star to Earth, Proxima Centauri, is 4.24 light-years away, which means light, traveling at 300,000 kilometers per second, still takes over 4 years to reach it. Our fastest spacecraft, Voyager 1, launched in 1977, is traveling at about 17 kilometers per second. Even at that speed, it would take over 70,000 years to reach the nearest star. Clearly, if interstellar travel is to become a reality, we need a revolution in propulsion technology, the challenge of distance and speed. So what's stopping us from building a spacecraft that can travel fast enough to make these journeys feasible? The biggest obstacles are energy, propulsion, and relativity. To reach another star within a reasonable time, say 50 years, a spacecraft would need to travel at least 10% the speed of light, about 30,000 kilometers per second. But here's the problem. Accelerating something to that speed requires an enormous amount of energy. Conventional chemical rockets, like the ones that took us to the Moon or sent rovers to Mars, are completely impractical for such a journey. 1. Major issue is the Tsiolkovsky rocket equation, which governs how rockets work. The equation tells us that to achieve higher speeds, we need exponentially more fuel. But carrying that much fuel means the spacecraft becomes too heavy, making it even harder to accelerate. It's a vicious cycle, one that no chemical rocket can escape. The theoretical solutions. So if traditional rockets won't work, what about other propulsion systems? Scientists have explored several ideas that, while purely theoretical for now, could one day make interstellar travel a reality. Nuclear propulsion. In the 1950s and 60s, scientists proposed Project Orion, which involved detonating nuclear bombs behind a spacecraft to propel it forward. While this might sound extreme, calculations showed it could, in theory, allow a spacecraft to reach 5 to 10% the speed of light. A more refined version, nuclear pulse propulsion, remains an area of interest. Fusion rockets. Unlike nuclear fission, used in power plants, nuclear fusion, the process that powers the sun, releases far more energy. If we could harness fusion efficiently, a spacecraft could reach a significant fraction of light speed. Concepts like the Daedalus Project, 1970s, suggested that a fusion-powered probe could reach Barnard's star, 6 light-years away, in 50 years. However, controlled fusion remains a challenge even on Earth. Antimatter propulsion. Antimatter is the most energy-dense substance known to science. When matter and antimatter collide, they annihilate, releasing 100% of their mass as energy compared to nuclear fusion, which only converts about 0.7%. A spacecraft powered by antimatter could, in theory, reach speeds close to half the speed of light. The problem: producing antimatter is extraordinarily expensive and difficult. We can only make nanograms at a time. Laser-pushed light sails. One of the most promising ideas in recent years is the Breakthrough Starshot initiative, which envisions tiny, lightweight probes propelled by powerful Earth-based lasers. By focusing a high-energy laser beam on an ultra-thin sail, a spacecraft could be accelerated to 20% the speed of light, reaching Proxima Centauri in just 20 years. But such a system would require a laser array far beyond anything we currently have. While these ideas sound promising, each comes with immense technical and engineering challenges. But the real hurdle isn't just speed, it's what happens. When you travel that fast, the relativistic effects of high-speed travel as an object approaches relativistic speeds, a significant fraction of the speed of light, strange things begin to happen. According to Einstein's theory of relativity, time slows down for the traveler relative to someone on Earth, a phenomenon called time dilation. This means that astronauts traveling at near light speeds could experience only a few years while decades or centuries pass on Earth. Interstellar travelers might return home to find that everyone they knew is long gone. Another major problem? Interstellar dust and particles. Even a tiny speck of dust, when colliding with a spacecraft moving at 10% the speed of light, would release immense amounts of energy, potentially causing catastrophic damage. Shielding a ship against such impacts would be a major engineering challenge. So if high-speed travel is so difficult, could there be another way? Some scientists believe the answer might lie in the very fabric of space-time itself. Bending space-time, theoretical possibilities, if traveling at near light speed is impractical. Due to energy limitations, relativistic effects, and physical hazards, could we take a different approach? Instead of moving through space at extreme speeds, what if we could bend space itself? This is where some of the most exotic and mind-bending ideas in physics come into play. One such concept is the Alcubierre warp drive, named after physicist Miguel Alcubierre, who proposed it in 1994. His idea was inspired by Einstein's general theory of relativity, which describes how space-time can be distorted by massive objects like black holes. In theory, a spacecraft using a warp drive wouldn't move through space in the traditional sense. Instead, it would contract the space in front of it while expanding the space behind it, creating a sort of wave that carries the spacecraft forward faster than light, without violating Einstein's laws of relativity. But here's the catch. To achieve this kind of space-time warping, the warp drive would require negative energy or exotic matter, something that has only been theorized but never observed. Some ideas suggest that quantum fluctuations in a vacuum could produce negative energy, but we have no way of generating or harnessing it in meaningful amounts. Wormholes, cosmic shortcuts, or science fiction. Another theoretical way to bypass the limitations of light-speed travel is wormholes, also called Einstein-Rosen bridges. These are hypothetical tunnels in space-time that could, in theory, connect two distant points in the universe, allowing instantaneous travel between them. If wormholes exist and could be stabilized, they would provide the ultimate shortcut for interstellar journeys. However, wormholes come with their own set of major problems. First, there is no experimental evidence that they exist. Even if they do, they would likely be extremely unstable, collapsing before anything could pass through. Some theories suggest that exotic matter with negative energy could keep a wormhole open, but again, we have no known way to create or manipulate such materials. Even if we could stabilize a wormhole, there's another unsettling possibility: time. Travel paradoxes. Since wormholes theoretically link 2 points in space and time, traveling through one could allow for time travel, potentially leading to paradoxes like the famous grandfather paradox, where someone could travel back in time and alter their own existence. The implications of this are unknown, and many physicists argue that nature somehow prevents such paradoxes from occurring. Artificial intelligence and self-replicating probes. Given the immense challenges of human interstellar travel, some scientists propose an alternative: let the machines go first. Instead of sending humans on dangerous centuries-long voyages, we could send autonomous AI-powered probes that could travel at slower speeds, explore distant star systems, and even self-replicate, using local materials. This concept, known as von Neumann probes, suggests that once a probe reaches a new system, it could build copies of itself and send them further into space, creating an expanding network of explorers. Breakthrough Starshot, the laser sail project we mentioned earlier, is one step toward this vision. Instead of sending massive spacecraft, the plan is to launch tiny, gram-scale probes that could reach Alpha Centauri in a few decades, sending back data about potential habitable planets. If this approach works, future AI probes could map the entire galaxy long before humans ever set foot outside the solar system. Are we alone? The Fermi Paradox and interstellar civilizations. The possibility of interstellar travel raises another profound question. If interstellar travel is possible, why haven't we seen any evidence of other civilizations? This is known as the Fermi Paradox, the apparent contradiction between the high probability of intelligent extraterrestrial life and the lack of observable evidence. One explanation is that interstellar travel is simply too difficult or too expensive, even for advanced civilizations. Another theory, known as the Great Filter, suggests that some catastrophic barrier, either technological, environmental, or self-destructive, prevents most civilizations from reaching the point of interstellar expansion. There's also the unsettling possibility that someone or something is actively preventing expansion, a hypothesis known as the dark forest theory. This idea, popularized in science fiction, suggests that the universe is like a dark forest, where civilizations remain silent to avoid detection, fearing that revealing their presence could invite destruction by more advanced beings. Could humanity ever become an interstellar species? Despite all these challenges, many scientists believe that interstellar travel is not impossible, just extremely difficult. History has shown us that what seems impossible today can become reality in the future. Less than 120 years ago, powered flight was thought to be a fantasy. A mere 66 years after the Wright brothers' first flight, we landed on the moon. If technological progress continues at an exponential rate, who's to say that interstellar travel won't be achievable in the next few centuries? Several long-term projects are already exploring interstellar possibilities. NASA, private organizations, and research institutes are working on nuclear propulsion, antimatter research, and even theoretical warp drive concepts. The biggest challenge isn't just technological, it's human willpower and sustained investment. If we as a species are committed to reaching the stars, we may one day find a way. But there's one final question we must ask ourselves. The future of interstellar travel, hope or hype? So, with everything we've explored, relativistic limitations, the mind-bending possibilities of warp drives and wormholes, and the potential of AI-driven probes, what does the future hold? Will humanity ever achieve interstellar travel, or is it destined to remain the stuff of science fiction? The truth is, interstellar travel is a monumental challenge, but it is not an impossibility. History has repeatedly shown that human ingenuity can break barriers once thought insurmountable. Just a few centuries ago, crossing the vast oceans of our own planet seemed just as daunting as crossing the interstellar void does today. The key lies in technological advancements, scientific breakthroughs, and perhaps most importantly, a willingness to dream big. The role of quantum physics in future space travel. While classical physics imposes strict limitations on speed and energy consumption, the field of quantum mechanics could hold the key to unlocking new methods of space travel. Some physicists speculate that quantum entanglement, the mysterious link between particles over vast distances, could one day be harnessed for instant communication, solving one of the biggest problems of deep space exploration. Another radical idea is quantum tunneling, a phenomenon where particles seemingly bypass energy barriers by jumping from one place to another without traversing the space in between. While still in the realm of theory, if this effect could somehow be scaled up, it might provide a method of teleportation or ultra-fast travel across vast distances. Could the next great revolution in space travel come not from engines and fuel, but from quantum physics? Some researchers believe it's worth investigating. After all, many of today's technologies, GPS, MRI machines, and semiconductors, were once considered pure theoretical physics. Merging human consciousness with machines, another possible solution to interstellar travel, isn't physical movement at all, but rather sending our consciousness across the stars. Imagine if, instead of transporting fragile human bodies, we could upload our minds into artificial systems, digital consciousness, robotic bodies, or even biological machines capable of surviving the harsh realities of space. This concept, known as mind uploading or digital immortality, is still highly speculative. However, rapid advancements in neuroscience and AI are bringing us closer to understanding how human consciousness works. Some futurists believe that one day we may no longer need spacecraft. We may become the spacecraft, existing as pure information that can be transmitted across the universe at light speed. Interstellar travel and the survival of humanity. 1. of the most compelling arguments for interstellar travel is simple: survival. Earth will not remain habitable forever. Whether due to natural disasters, climate change, nuclear war, or cosmic threats like asteroid impacts or supernova explosions, our planet has an expiration date. If humanity wants to ensure its long-term survival, we must become a multiplanetary and, eventually, interstellar species. Visionaries like Elon Musk have already taken the first steps with plans for colonizing Mars. But Mars is just the beginning. To truly secure our future, we must look beyond our solar system. If we can develop the technology to settle other star systems, we could create a backup plan for civilization, one that ensures humanity thrives long after Earth is gone. The final question: is interstellar travel inevitable? Looking at everything we've discussed, one thing becomes clear. We don't have the answers yet, but we're getting closer. The laws of physics don't outright forbid interstellar travel, they just make it incredibly difficult. With each passing decade, new breakthroughs in propulsion, quantum mechanics, and artificial intelligence bring us a step closer to making the impossible possible. The real question isn't whether interstellar travel is possible. It's whether we, as a species, will choose to pursue it. Will we invest the resources, make the sacrifices, and dedicate the centuries of effort needed to reach the stars? Or will we remain bound to our small corner of the galaxy, forever dreaming but never daring? Maybe, just maybe, someone watching this video today will be among the first humans to set foot on another star system. So what do you think? Is interstellar travel humanity's destiny, or just a beautiful dream? Let us know your thoughts in the comments below. And if you enjoyed this journey through the cosmos, don't forget to like, share, and subscribe for more mind-expanding content.